that also had problem 11. So I didn't know which one y'all wanted to look at.
This is before I ask the question. This is what my answer looks like. Is that what it's supposed to look like?
That's why it says the y-intercept is 100, not 10. The balance should be, yes, it's, I think, pretty much there. So they gave us the graph kind of deal. Try again. Yep. So we have this here. We have the graph. And they gave us this little kind of Z bar. And that all that's saying is that there's a break in the graph. So instead of going 0 to 100, it jumps up to the next spot is 110, 130, 150, and it gave us this point here as 0, 100. It went up this direction here. We have 4, 140, and the student response was that the slope is 10, so after 7 years, the balance is 70. Well, here we went over 4 and up, well, 40, yes? So the slope is indeed 10. So there's nothing wrong with that part of the statement. But if we go 7 years out, we're going to go up 70. That's just what the slope is saying, yes? Yeah. So our new point after 7 years is going to be what? 7.
70. So 170.
170, yes? That's what it should be, and he said it was at what?
70.
Yeah.
So he was right about going 10 up every year, but he started with the wrong.
Right. The initial point, the y-intercept was not 0, it was 100. Because the y-intercept, where it started, should start at, and he started at 0. So we could say in some way, we either say he started at 0, he had the wrong y-intercept, he had the y-intercept as 0 instead of 100, something along those lines. Does that make sense? So that is identifying the error. So we identified it there. Now we correct it by saying, instead of saying 70, it should be 170, because his statement was what again?
The slope of the line is 10, so after.
So yeah, so the slope of the line is 10, or we can just say after 7 years, the balance is 170. So when it says correct it, all we're doing is whatever they got wrong in their statement, we're fixing it.
We go over 3 on 4.5.
Okay. So by the way, you will need a graphing calculator today, because you just put that up. Why don't y'all go on and plug it in and see what you get, number 3. What are we looking at, 3?
Yeah.
They do have some.
Isn't that what you were showing?
So that graphs it, just does graphing.
Wait, would there be 4? Like 3, 4?
3, 4.
Wait, what number?
3.
3 on the homework.
Oh. Which one?
1.5. Now, for this here, we need an eliminator equation if we're doing this by hand. Yes? Okay, so if we do this by hand, we need an eliminator equation to work with this here. Let's eliminate x out, and I'm going to use the middle one. X plus y minus 2z is equal to 5. It's going to be one of the two equations we use. And this is the other. Now, luckily for us with the eliminator equation, we don't have to do anything for the first equation. Now, for the other, we're going to multiply everything by 2. We're going to multiply this whole equation by 2, giving us negative 2x plus 4y plus 2z is equal to 4. Now, for the one on the left, since the signs in front of x are opposite, we would add. X plus negative x is 0. Y plus 2y is 3y. Negative 2z plus z is negative z. And 5 plus 2 is 7. For the other side, since our signs are again opposite, we're going to add 2x plus negative 2x is 0. 3y plus 4y is negative z plus 2z is positive z is equal to 13. Now at this point here, we could eliminate y next, but I would rather eliminate z because the z's are already the 3y minus z is equal to 7. 7y plus z is equal to, at this point here we can add because the signs in front of z are opposite. These would cancel. 3y plus 7y is 7 plus 13 is 20. Divide by 10 telling us y is.
Wait, so you can do that on.
And then you just put it all.
Is it the same thing that you taught us last time?
Yep. So now we can plug it back in. 3 times 2 minus z is 7. We'll get there. 3 times 2 is 6. 6 minus z is 7. Subtract 6, so negative z is equal to, or z,
Okay.
because we have to divide by negative 1, telling us z is negative 1.
That's so easy.
And lastly, we have to plug it back in for x. And I know I'm running, that's purple. X plus our y value is 2, minus 2 times negative 1 is 5. So we do have positive 2, negative 2 times negative 1 is positive 2. So we have x plus 4 is 5, minus 1 telling us x is positive 1, not negative 1. So yeah, so our solution is 1, 2, negative 1. Yes. That's today's lesson. Yeah. No, they're a day ahead.
That's why I stared at you.
I was like, what are y'all?
Yeah.
Yeah, what about that?
I mean, this is how to do it. Now we'll dig into the lesson here.
You're gonna say that we just knew how to do it.
Yeah.
Oh, I'm sorry.
You're good.
Vince told me 2 hours ago that y'all were.
Yeah.
Give me more.
Okay. Let's go on and look at this here. Now, part of the reason, because y'all know where we're going, that we're doing this, that we did all this the last 2 days, learning how to do this by hand, is so that you understand what we're doing, or what we do when we solve a 3-variable system of equation, what we're looking for. Now we're going to see the quicker way to do it. Now the first part in this is writing, or talking about matrices. Now, a matrix is a rectangular arrangement of numbers. It could be square, the number of rows and columns are the same, or it could be like this here. And our dimensions is the rows by columns. So in this case here, we have 2 rows and 3 columns, so it's a 2 by 3. Questions on this so far? Now, a matrix derived from a system of linear equations, each written in standard form with the constant terms on the right and the variables on the left, and the variables are going to be listed in alphabetical order, which means x, y, z, or x, y, is called an augmented matrix of the system. For example, the system below can be represented by the given augmented matrix. Yes? You don't have to write that. Yeah, I know. So what they did is they took this 3 variable system of equation and we wrote it as an augmented matrix where the coefficients are on the left and what it's equal to is on the right. Okay. Now before we start doing anything with the calculator, we're going to work on writing augmented matrices. So when we look at these here, the left side we want to be the variables only. Variables and their numbers, which we do have. The first equation does have x, y on one side, what it's equal to on the other. Second equation, x, y, what it's equal to. So we do have that. Coefficients over here, constant terms over here. But we do want the variables ordered x, y, z, alphabetical. Well, the first one, we need to rewrite it. We need x first, yes? So we're just going to switch it. So we're going to put the negative 2x first, then we have what? Plus y is equal to 1. We're just flipping them. Because the y is positive and the x has the negative 2. So we get this here. Questions on this here? The only reason we would need to add or subtract is if it was on opposite sides of the equal sign. We're having to move it across the equal sign. Now we don't have to rewrite it. I'm going to go on and rewrite the other equation next to it. So we get this here. Because the second equation, x plus 3y equals 12, x is first, y is second, it's fine as it is. Questions on this here? Now when we write the augmented matrix, we're just taking the numbers in front of the variables and then what it's equal to. So going across the top for the first one, what is our first number going to be? Almost. Negative 2. Then the next one is? And the last one is? There is the augmented matrix. Questions on this here? Now we need to state the dimensions. How many rows do we have? How many columns do we have? So this is a questions on this here? Yeah. Let's look at the next one. Are both of them in the correct form? We need to rewrite the top one as? We don't have to move the second one over because the second one's already in the correct form. So writing the augmented matrix for our first row would be what? Almost. Because we take the signs with it. Questions on this here? I feel comfortable with this so far. Yes? And what would the dimensions of this be? 2 by 3. 2 rows, 3 columns. Yeah. That's our full answer. A little bit longer. Because if we look at this here, are all three equations written in the correct form?
Yes.
Because the top equation, we have 3x minus 4y equals 7 minus 2z, yes? We said alphabetical order and all the variables have to be,
No, say on it says like y is first. So on the
alphabetically, what comes first, x or y?
y. No, wait. No, it's x. What am I doing? My life.
Where is z? Is z on the correct side for this equation?
No.
We need to move z from the right side to the,
Yeah, that's very embarrassing.
so we need to add 2z, which will tell us that we have 3x minus 4y plus 2z is equal to 7. So we have this written in the correct form. We need all the variables on one side and the constant term, the number without a variable, on the other. We're not using this anymore. The second equation, all the variables are on one side and they are indeed in the correct order. And the last one, all the variables are on one side and it is indeed in the correct order. So let's start writing this matrix. So what are our numbers going across the top for our first one? Exactly, it would be
Oh, negative.
middle row.
9, 3. Wait, where's the 0?
There is no z.
Oh,
If there's a variable missing, we put it in as 0. The caveat I will add to this is that that variable has to appear in the other ones at least once. And let's do the last one before I dig.
or -1.
So we have this here because z showed up in not just one of the other equations, but two of them. We need it in all three. Now, if I go back to the previous one, here, in either equation did we have z? No. So I don't need to add a column for z because z did not show up in either equation. If one of the variables shows up in at least one of the equations, we need it represented in all of them. Does that make sense? And if it's missing, we put it in as 0. And this would indeed be a 3 by 4. Questions on this here? Be ready for the next one. Okay. Are all the equations set up correctly? X, Y, Z, X, Y, Z, X, Y, Z, and our numbers. So going across the top for the first one.
-3. 0. Wait, what?
So 8,
Oh,
yes. 1,
My bad.
5,
And then 2, 1, and then 4, and then 2. And then 9, and -7, and -3, and -6.
this is a. Questions on these here? We ready for the next one? Yes.
Is it really just
Yeah.
You ready to do the next one? Okay.
Wait, what? Yeah, that's what I'm saying. We have this.
This should look familiar.
Isn't that an old problem?
It's the last
Did we
one.
already do it?
Yeah, we just did this one.
Oh, okay, your turn. That's
Yeah.
I was tripping. I was like, wait, what? He said this should look familiar.
I think if you go back and watch second hour's video, we do that problem twice. I didn't even notice.
That's so funny.
So,
Did anyone say?
no. They just did it again. It's like, okay.
Did you say we just did it again?
No, they just did it.
Yeah.
To be
I
honest,
said,
went with it. I went back to it.
I said we because I did it with them.
No, Taylor started saying we, and so I was thinking he meant he was there.
I don't know.
I was like, are you taking two math classes or something?
Are there questions on this here? Do we feel comfortable with writing augmented matrices?
Yes.
Okay. In that case, we will move on to solving systems of equation with technology. So many technological tools have matrix features that you can use to solve a system of linear equations. The augmented matrix in example 2, rewritten in reduced row echelon form, is shown below. Observe that the solution in this system is negative 1.4, 5.2, and 16. And you can verify this solution in your original system. Now, when we set it up, we had x, y, z, and this is the number that it was equal to, yes? And when it's set up in this form, the first row is telling me that I have x, 1x, plus 0y, plus 0z is equal to negative 1.4. Well, 0y and 0z are really gone. It's just telling me x is negative 1.4. The middle one, 0x plus 1y, which is just y, plus 0z is 5.2. This is really just telling me y is.
So is it easier to do it like that or by
So this is the calculator answer, what we'll get to. But really, when we look at this, that diagonal of 0, this is what it's telling us, because this is our x, this is our y, this is our z. Everything else zeroes out. So that's how we know the top number is x, the middle number is y, and the bottom number is z. Now, if you put them in a different order, the variables will be arranged just in a different way. But we do need to make sure all the x's go first, all the y's go seconds, all the z's go third. So this is the x value, y value, and z. Does that make sense? Okay. Now, let's actually see how to work this. So we look at this here. These are the steps, and I gave you these here. I'm not going to dwell on those. Now, the problem there, we're going to use the calculator to solve this system of equations. Now, there is a whole bunch of pictures right there. Those are just the picture, what the calculator is showing you or should show you at each step. Now, the first thing we need to do.
Oh, never mind. It's like very small.
Yes, because I added that there so that it's all in one page. Now, we want to write this as an augmented matrix. So going across the top, our numbers would be 1, 1, 1, 2.
1,
And this matrix is a 3 by 4. I think so. I mean, I think we wrote it as an augmented matrix, possibly. Or something close to it. Okay. Now we want to solve this here. So go on and grab the graphing calculator. Now, the bottom half of this screen, where it does say clear at the moment, I'm going to clear it. This is the key history. So if you're looking at the keys, it will populate them as I type them. So the first thing we're going to do is hit second, x to the negative 1, second matrix. And it should look something similar to this. You may not have all the 2 by 3, 2 by 2, 2 by 2, and 3 by 4, but we do get here. Yes? Now this here is recalling the matrices. So if I want to do stuff or add, subtract, multiply, do anything with matrices, we'll recall them here to actually do operations with them. But what we need to do is edit. We actually need to put the matrix in. So we'll go over to edit, and we'll hit enter because we're going to put this into matrix A. Now the dimensions of the matrix were a what? 3 by 4. So I'll do 3, enter, 4, enter. If you hit enter after you type the number in, it'll move to the next spot. So I hit 3 and enter, so it moved over to the columns, 4, enter. Now we have this here. Questions on this here?
It was 2
change it. Did you change it? Yeah, no, I meant you have to change the number. If you're changing the number, what's mentioned again?
Oh.
Yeah. Okay, yeah, you're right where we're supposed to be. Now, let's put the first row in, because the first row was 1, 1, 1, 2. So we're going to go 1, 1, 1, 2. Now, yours might not show you the whole matrix all at once. So it'll show you at least 3 rows and 3 columns at a time. Now we're just going to keep going. I'm going to go to the next one, which is 2, 3, 1, 3. And the last one, 1, negative 1, 2. Once you get the whole thing typed in, go second mode, second quit. And it should take you back to the home screen, which either has some calculations there or nothing. So one of the two. So just,
It's the
Second
same
mode,
thing.
yeah,
It's the same thing.
yeah.
I already did that. I thought the same thing, and I did quit twice.
So, yeah, second mode, what we're doing is second quit. Because second, the blue button, anything blue above the keys is what it's going to do. So mode thing is quit. So we good with this so far?
by your second.
So you first quit.
Then you press second and then mode.
Okay, we're ready for the next step. Second matrix. So we wanted to get it into reduced row epsilon form, R, R, E, F. And to do that, we're going to go over 1 to math. Second, x to the negative 1. Then we go over so that math is selected at the top. And now in this list, we need to find R, R, E, F. So you're going to scroll down. And we hit enter when we find it.
You edit these.
No. Yep. So we all have this here, yes? We all good? Now the next thing we need to do is recall the matrix. And to do that, we're going to go second matrix, second that x to the negative 1. Now, we put it in matrix A, yes? So it's selected. Go on and hit enter. So,
Press second and
matrix.
and then press enter. You just enter.
Enter again.
Yeah, and then you just press enter again.
Wow.
See if you can
So let's see.
press this. Press enter and then yeah.
What is this giving me?
The solution.
Oh, it's already the numbers. Like,
Oh yeah, and then this.
1, 1, 1.
so this is giving me what we just learned.
Or what we solved the other day, yes. Because so the first thing we need to do is actually put the matrix in. So when we went second matrix over to edit, we needed to make it a 3 by 4. So this here, so that what we had, we're typing it in. So I go 1, 1, 1, 2, 2, 3, 1, 3, 1, negative 1, negative 2, negative 6. Then we go second quit, second matrix over to math. We find RREF. Second matrix A. And we get this here.
What did I do?
I think you just typed in the matrix that it had before. It didn't type the whole thing in. Now what this tells us is this last row is the solution. Where the top number is x, the middle number is y, and the bottom number is z. So negative 1, 1, 2. And that's the solution. So we solved this one already, yes? Now, as an augmented matrix, this would be 1, 1, negative 2, 5. Yes?
Y'all doing the problem.
Yes.
The next one would be negative 1, 2, 1, 2. And the last one's 2, 3, negative 1, 9.
Wait, which one?
So this is the homework problem number 3.
Oh, this is homework.
Homework problem number 3 from yesterday.
Oh, oh,
So this is the one we started class with, yes?
oh, yeah.
So I'm just going back to this here. All right? So let's look at this here. So I could grab the calculator, go second matrix, over to edit, and do 3 by 4. All right? And we could type it in. So it was 1, 1, negative 2, 5. Negative 1, 2, 1, 2, and 2, 3, negative 1, 9. So that's the one we did, yes? Second quit. Second matrix, over to math, and we find RREF. Second matrix A, enter. And it tells me that the solution is 1, 2, negative 1. And we found by solving it by hand was
This is just so much easier than solving it,
by hand.
okay.
Because once we get the hang of typing this in, you're going to be a lot faster at doing these.
I absolutely frustrated whenever I try to do it back.
No. I'm going to give you more time tomorrow.
So we get homework for this in here.
You can take them home, but I'm going to give you time to do them in here. So, tomorrow. All right. Let's look at one more. All right, guys, we're going to do one more today. So, looking at this one here. So, we want to write it as an augmented matrix first.
So 2, 3, negative 1. 3, 9, negative 9, 9, negative 12, and then 4, negative 3, negative 1.
And this is a 3 by 4. Questions on this here? So we good at writing this in an augmented matrix. Now the next thing we're going to do is we're going to grab the graphing calculator. We're going to go second matrix. Over to edit, and we'll hit enter. Yep. 3 by 4, likely it's already there. We can say enter, enter. And now we're going to enter the first row. So we'll have 2, 3, negative 1, 15. 3, negative 9, 9, negative 12. 4, negative 3, negative 1, 19. Second quit. So we got back to this here, yes? Now we go second matrix, over to edit, and we want to find RREF, which is right here, and we'll hit enter. Then we go second matrix. We put it in the first matrix A, so we'll hit enter and enter. So we get 5, 1, negative 2. Yes? Yep. So the answer is 5, comma 1, comma negative 2. And that's it. Questions on this here? So
3, 4, 5,
for yesterday,
1.5.
3 through 5, 11, and 13.